Tucker's going to talk about AITC at the ANU. He's an astrophysicist, cosmologist at the Research School of Astronomy and Astrophysics, Mount Stromlo Observatory, and the National Centre of Public Awareness of Science at the ANU. He's one of the leads of the Kepler Space Telescope Q program to understand why and how stars blow up. He's also leading a project to build a network of ultraviolet telescopes in the upper atmosphere to search to find Planet 9, a hypothetical new planet on the edges of the solar system, as well as a new mission. Can you find a hypothetical planet?
Huh. Well, you know, there's hypothetical intelligent life too. Yeah, so kind of like Nick, I moonlight as someone who knows what they're doing. And so talking a bit today, and Melissa will take over a bit. So Mike in previous, Pekovic, who a lot of you know in previous incarnations, has talked about the AITC. And we'll give a bit of an overview. The key message today with the AITC, though, is the funding model for the AITC is changing. And what that practically means is that the cost effectiveness is being brought down in the sense that for groups who are regularly producing satellites, like you guys and Auckland and DST, that through collaboration there will be access to the facility at a cheaper rate. For the startups and the smaller businesses in the room, the ATP government will be funding the facility to make it more efficient for the groups that can't afford it, and Melissa will go into the details about that. So the AITC is this weird building up at Mount Stromlo. So Mount Stromlo's been around for 100 years, and we've shifted from astronomy to doing actually optical munitions during World War II, and we can talk about it. And the primary goal was always telescope mirrors and polishing and building large telescopes and instruments. In 2003, after the bushfires that destroyed most of the observatory, there was a shift to more advanced instrumentation. We no longer needed just to build mirrors because you can build them cheaper in the US. And it was realized quickly that the instrumentation that you would need to build big space telescopes, or big ground-based telescopes, is all the same stuff that you need to do small sats in terms of the testing. And therein is where the AITC was born, and a number of you in this room I know have paid time with it and been yelled at by Mike Pekovic, guided by Mike Pekovic. And so there's a lot of the facilities that you need to do small sat and CubeSat testing. I mean, I'm not going to talk in detail about all of these, but there's a large thermal vacuum chamber that gets down to a 10⁻⁹ torr, due through a range of temperatures to get your approved testing. There's vibration testing, shock testing. There's also smaller rooms for more instrumentation for plasma processing, surface tests, mass properties, mass measurements. These facilities haven't changed over the past few years, so if you've used them previously or if you've been around and heard from Mike or previous people talking about it, that hasn't changed. And sometimes even we let our engineers pose for CubeSats. The other part of this is not just the actual facilities or the instruments that can be used for CubeSat testing and small sat testing, but the systems engineers and optical engineers that are available to be used, the access to some of the labs, and in the changing scheme of this large building, the upstairs that overlooks the second part of this, so this has the thermal vacuum chamber and the anechoic chamber. In the next room through these doors is the shock testing and the vibration testing, the shaker table, and the large clean room. The upstairs area will be made for small companies that want to come in and do testing. You can set up shop there for a number of weeks while you're getting ready, so you can essentially, you don't have to just fly in, fly out, but you can collaborate and use it as a collaborative space. So it's trying to do to what, you know, Andrew, you touched on earlier, and is this push that as the Australian Space Agency, it's working together and get a lot of wheels running in the same direction. And having the facility here is more than just us using it. It is a national resource, and that's where we want it to head. Not that it's just on the top of the hill at Mount Stromlo, which is quite nice. It overlooks Canberra. It was a balmy -3 when I woke up. It's still shorts weather in Canberra. It's no New Zealand. But it's evolved over time. So obviously, I don't have to go through this. A lot of you who've been through this, but the primary goals of the spacecraft testing are to get your launch approvals ready. So those are the key aspects of shaking, vibration testing, thermal testing. As a bare minimum, some groups need additional testing that you want. But there's also the ability to do your developmental, your engineering assessments. I'll just point out this picture. Mike has back turned. This is Anna Moore. So she's the new director of the AITC. She took over beginning of last year, and quite a few of you know her in this room. She couldn't be here, unfortunately. But she's kind of brought this vision of, even though she comes again from the astrophysics regime, she's built instruments all over the world, including in Antarctica, and really wants to make it to allow Australia to start doing some of these big missions and having a lot of the groups work together as part of these more lofty, ambitious ideas. And one of the ways you do that is to use the resources you have, which is the space testing facility. As mentioned, a lot of the QB50, or all 3 of the QB50 satellites were tested in here. So these are all 3 that were tested simultaneously in the thermal vacuum chamber. But we've also tested Buccaneer, and Auckland, I think, is coming August?
August.
Yeah. Yes. So it'll still be cold, sorry. And this is the point, is that we want it to be open to anyone that wants to use it, both in Australia, New Zealand, and even in the greater region. And in the past, most of the inhibition was lack of expertise or knowledge of how to use the facilities, but also just the cost. And that's essentially what we're addressing now. We've partnered with a number of you in this room. We have new partnerships with DLR, so the Germans, and Airbus in a number of projects, also Korea, and, sorry, I don't know what, DSTG didn't come up well. CNES is going to be meeting with us later in August too. And again, it's using the capabilities of, yes, we're academics who have focus on sometimes doing science-driven projects, but also allowing the technology demonstrators and engineering focus to come play internationally. So what I might actually do is let Melissa take over about what this financial stuff actually means in these grander schemes.
Thanks, Brad. So I'm Melissa Simeon, and I'm Chief Operating Officer at the Advanced Instrumentation Technology Center. I come from physics background, so I'm not an astrophysicist or a space scientist, but I have a great interest in facilities and science that goes behind. As Brad mentioned, so the facility was built many years back in its initial stage, and then 3 years back in its final stage, where we have a full suite of facilities. As it usually goes, government has invested a lot of money in building these facilities, but of course didn't allow for any operating budget for the center or for space test facility. So we ended up as a university having this add-on onto the astronomy department, which we had to develop and make it financially viable. Because center also, Brad didn't mention, Advanced Instrumentation and Technology Center is purely commercial center, so we receive very little funding from university, and all of our funding comes from external projects. So therefore, it was very important for us to develop a business model that's sustainable, but it also serves the community. So one option we came up this year is to basically develop space test consortiums. So what would that mean is that for big players and for big partners, we will have a subscription model in which people can and companies can buy time on facility, and that means also buying an expertise. And at the moment we have about 5 partners lining up for usage of the facility, and they are quite big organizations like University of New South Wales in Canberra, like ACT government. We are in negotiations with New Zealand Space Agency, so opening this facility to also New Zealand. and not only New Zealand universities, but companies as well. And although what we proposed as the initial fee is quite large for the startup community, the idea is that agency like Space Agency, Australian Space Agency, New Zealand Space Agency, and local governments would actually fund access for startups to use the facility. So in order for this to work, we need to develop a pipeline of business. So we need as many of you to use facility as possible in the next 2 years and to demonstrate that this can become a national resource and national facility as well. So basically we need to work with each of you to get this facility running. And what's new is that the ACT government just recently through key capability platform invested some funds into the facility and allowed us to have longevity to have facilities, proper facilities manager, so that we can allow small startup and businesses to actually use facility and provide the support for the facilities. So if you know, you will have tests coming up. So for all of the partners that are developing small sats, we want to hear from you because we can then plan the pipeline. We also want to hear from launch providers because we do want to partner with launch providers to have that supply chain as well. And any other businesses that would find this useful. So facilities are not open only for space science, they're open also for other disciplines who can use big chambers and shop facilities. So, is there any questions?
Yep.
Yeah.
Have you guys estimated the demand for services at your lab?
So demand is quite low, I can tell you that. I mean, in the recent 2 years, we tested QB50 and Buccaneer, and we are testing Raptor 1, so that's about 3 missions. So the demand is low, but around the world, demand for these kind of facilities is quite high. So with DLR, for example, we are in negotiation to become like a second site for DLR when their facilities are all hooked up. So that's why we need community to get behind it so that we can have a pipeline of what. I mean, AIPC is not only just facility is just one part of our business. So we do have a quite well-developed R&D program. So we are not relying only on the facility to make it sustainable. But yes, at the moment it's quite low, it's quite sporadic, and in the past it was expensive as well. I mean, if you think per test, I think it's about between $30,000 to $50,000 to pay for this facility. So we need to kind of get the costs down so that we can have as much as possible. Yeah.
Do you plan to charge per satellite or per day use, or
So
if you go to IBG, they charge
so
per
this
day?
will be so for partners who are chipping in on the $100,000 level, they will have about 5 weeks. It can be in multiple blocks, so it doesn't need to be I need 5 weeks now. It can be 3 days here, 5 days there. But in the past we were charging per test, so we will estimate and give an estimation how much it will cost to test.
I guess my question is 5 weeks in a TVAC chamber costs a lot more than 5 weeks on a.
Yeah, exactly. So this is just an initial phase. So we will have a time use committee established with initial partners, and then there are talks also that we will have like a point system. So yes, not all of the facilities will have the same values. So if you're using something like cheaper than other things, so that will be kind of points that will be dedicated to each facility, and then you can kind of go through your points until you exhaust everything. Yeah.
Essentially, the problem was always before every initial test was treated as a separate project with all the
And
high
there's a separate contract.
and
basically,
with
yeah.
all the
Yeah.
high ANU like
Overheads.
university overhead fees and the glacier speed of university contracts, and it just wasn't efficient.
It's not just university contracts, I guess. Are you speaking to IABG then about how they test? Because that's the,
We will,
that's the
yeah.
BML.
Yeah.
What about the cost for a startup?
Yes.
Bringing in a one new Cubesat.
So basically, the startup, we want to leverage JCT government funding. So what startups and small companies need to do is contact us on the ABC at ANU.edu.au, tell us what they need, then we work with the startup and the company to really tease out what the requirements are, and we want actually to reduce the cost to the minimum. So if we can do it for free, we will try to accommodate that through the SDR grant. Yeah.
Yeah, yeah.
Yeah.
All right, great.
Excellent.
Thanks very much.
Thanks.
You too.